Our last target in our matter unit is assess the changing organization and structure of atoms to explain chemical and physical changes. Or in other words, are things undergoing a physical or a chemical change, and then what are their particles looking like? So in order to talk about physical and chemical changes, we first need to talk about their physical and chemical properties. So matter can undergo physical or chemical changes based on their physical or chemical properties. So for example, a physical property is a characteristic of a substance that can be observed, meaning using your senses. So things like sight, sound, or feeling, so touch. And we observe these without changing that substance into something new. So some types of physical properties are the hardness of an object, so whether it's hard or soft or somewhere in between. The odor of the object, whether that's a sweet or pleasant smell, or foul, meaning it's not very good. The shape of the object is something we can observe, whether it's round or angular. The texture of an object, meaning is it bumpy or smooth. Sometimes you'd be able to taste the physical properties of something, so whether it was sweet or sour, although this is sometimes referred to as some of their chemical properties. The density of an object, which we've learned in our first target for this unit, that is the ratio of mass to volume. Something that's easy also to observe is the color of an object. So we look at the kind of the spectrum of that visible light. So red, orange, yellow, green, blue, indigo, and violet, the colors of the rainbow. Another thing we'd have to consider, especially in chemistry, are the freezing, melting, or boiling points of an object. And the last thing we look at is the viscosity. Now, we've heard this word a couple of times, and this means that it's the resistance of a liquid to flow. So, for example, honey is more viscous, has more viscosity than water, because honey is stickier and harder to flow. And that's related to the object's density as well. So if these are the physical properties of an object, then what's a physical change? Well, a physical change is one which is easily reversible and no new substances are formed. So to put it in more kid-friendly terms, it's going to look different, but it's not going to be different. So again, it's not going to be different, it's just going to look different. So some of the examples of physical changes which we're going to be really familiar with are the phase changes we talked about in our last target, such as melting, going from a solid to a liquid, condensation, which is going from a gas to a liquid, and sublimation, which is going from a solid to a gas, or vice versa. The separation of mixtures by using density, so like the density tube. Magnetism, so on our matter stations you used a magnet to separate baking soda and iron. Sifting or filtering, like in our liquid mixtures lab, or using evaporation, which you will probably use in our upcoming Unmix the Mixture lab. The third one is the expansion and contraction of a substance when it's heated or cooled. So like the size would change, but then if it's cooled again, it would go back down. So it's still the same object and still the same physical properties, but it's not a new thing. It would just look bigger. So chemical properties, on the other hand, there's far fewer of them, but they make up most of our study here. So a chemical property are characteristics involved when a substance interacts with another substance to change its chemical makeup. So the three main types of chemical properties we're going to look at are flammability, which is the ability to set on fire, which I know a lot of you will be really excited about. We'll look at oxidation or rusting, which is not as exciting but still very relevant. So that's when substances react with oxygen, thus the term oxidation. And the reactivity, which I think is actually what you're most excited about because that's the ability of a substance to react with other substances. So these chemical properties all come into like chemical changes. So a chemical change is the one which is not reversible, and so a new substance is formed. And there are 6 main signs that a chemical change is occurring. So the first is that there can be a change in color with what you're working with. So for example, if you burn sugar, that is a really, really great example of flammability. So it's going to go from this white powder to black, kind of tar-like. So that's a definite change in color. In addition, there's definitely a change in smell there. In some chemical reactions, you'll see that there's going to be a production of heat, which means it's an exothermic reaction, because heat is exiting, EX. Or the reaction can get colder. It takes heat from the surrounding area. So it would mean that it's an endothermic reaction. Sometimes gases are produced, and you'd see that because it would be starting to bubble. So there'd be bubbling or fizzing. You can hear it. In some cases, a precipitate or solid is formed, and those would just kind of gather at the bottom of a test tube. Or, in really special cases, light is given off. So in fireworks, that's when we set different chemicals aflame, and that's what makes all the colors. So some examples of chemical changes that you're probably really familiar with. The first one is the rusting of iron. This is also known as oxidation. And you'll eventually learn what the following equation means. So if you have iron, and it's a solid, and we add oxygen gas, which is always O2, G is for gas, this will create iron oxide, so Fe2O3, which is that red solid that you see on old cars. Another example I'm sure you're very familiar with is the decomposition of substances. So if you let like a banana sit out too long, it turns really black, and usually that gets really sweet, but then it'll start decomposing, so it'll rot. And the third is the kind of the most basic and kind of the point we're trying to drive home, is that a chemical change is creating a new substance out of 2 different substances. So there are 2 questions you have to ask yourself when you're defining physical and chemical changes. The first one you're going to ask yourself is it still the same substance? And if so, then it's physical change. If not, it's a chemical change. And the second question you ask yourself is, can I reverse this process? If yes, then it's a physical change. If no, then it's a chemical change.